Hi everyone, I am Ekalaiva Abhishek from IIT Guwahati, Cohort 1. So, this is my third project. So, I am presenting my machine learning project today with the name AI based household electricity bill forecasting and energy consumption analysis system. Here, the primary objective of this project is to forecast future electricity bills using historical household energy consumption data and machine learning techniques. Unlike a conventional electricity calculator, the system learns consumption patterns from real world household data and predicts future bill values based on appliance usage behavior. So, the problem statement is electricity consumption is affected by multiple appliances operating simultaneously within a household. Most users only see the final electricity bill and do not understand which appliance contributes most to consumption, how appliance usage patterns affect future bills of them, how historical consumption can be used to estimate future energy cost. The, the objective of this project is to develop a machine learning model capable of forecasting electricity bills based on appliance level energy consumption. So let's get started. For this project, I used the REFIT electrical load measurement dataset, where 20 real households, as you could see here, these are all the households until CSV files, households, where these in these files, smart meter measurements and appliance level energy readings, aggregate household consumptions are being provided. Initially, all household datasets were stored separately around 20 different households. Each file contains time-stamped appliance consumption readings along with aggregate household consumptions. Now I'm combining all the datasets into a single dataset. Initially 20 separate households. So after integration 20 million records. As you could see here 1 million for one household. So 20 households it's 20 million records and 13 attributes we have. Result in combined refit CSV. So next, temporal aggregation. The raw dataset contains high frequency timestamp readings. So machine learning models cannot effectively predict electricity bills using individual timestamp readings. So therefore, time to month conversion was performed. After grouping house and month, so monthly appliance consumption values were generated. House and month. This is a monthly energy dataset.csv. Electricity units were derived from aggregate consumption. For billing purpose, then a billing function was applied with this electricity units. So I made a tariff slabs according to the government issued or somewhere. So 0 to 100 units, it has been calculated as a rupees 3 per unit, and for 100 to 200 units, it's 5 rupees per unit, and above 200 units is rupees 8 per units. So this created the target variable. So as you see here 100 for 3 and 205 and for 8. The target variable is continuous numerical data. So therefore, I used a regression, which is an appropriate machine learning approach. For model training, I used a random forest regressor instead of a single decision tree. So instead of relying on a single decision tree, it creates multiple decision trees and combines their prediction. This reduces overfitting, handles non-linear relationships, and works well on structured tabular data. These are those appliances 1 to 9 which we do have in the each households. So also I used model training. The dataset was divided into 80% training data and 20% testing data using the train test split, which is builds. These appliances represents appliance level electricity consumption aggregated on a monthly basis. Since the target is a continuous numerical value, this project is a regression problem. So let's go with the model evaluation, where the model was evaluated using a standard regression metrics. Let me do it. Model dot. In the meanwhile, let me explain. So these mean absolute error and mean squared error, which we get the results. So mean absolute error, which is getting a 242.77. This measures the average prediction error, better actual and predicted bills, and root mean square error. So RMSE, which is mentioned here, this is a 399.57, measures prediction error while giving more importance to larger errors, and the R square score. This is absolutely like 0.6053, so which is a 60%, 60.553 percentage. So this means the model explains approximately those 60.53 percentage of the variation in electricity bill values. This indicates that the model successfully learned meaningful relationships between appliance consumption patterns and electricity costs. So can hide this and let me predict the value which I have provided. So these are all the 20 data sets where 20 households. So I have to select one of the house. So let me select as ninth house. If I enter, this will ask the watts of the what are all the devices watts the power consumption. So I will take air conditioner as 1800, refrigerator 1500, machine 500, so water motor 400, induction 1600, ceiling fan 50, lighting 35, charge at 20. So how many hours they are using? So AC for 8 hours or something, like a refrigerator 20 hours, and TV for 6 hours something, washing machine around 2 hours, fans it's 18, charges 2 or 3. So we will get the result. So from, if you are watching from here, monthly energy analysis, whatever the power which I gave, and with the costs, like the time which it consumes, it will give the percentage of which is using more and where it is. So this results in the household 9 is having the predicted next month bill maybe a 460 rupees, and estimated monthly units is 1691 kilowatt hours, and this refrigerator is the highest consumer, which is occupying 53.2 percentage of the total bill values. This is what it calculates. So the conclusion is like this project successfully applies machine learning to forecast household electricity bills using historical energy consumption data collected from 20 real household in the datasets. So this project combines large scale data processing, feature engineering, random forest regression, electricity bill forecasting. Thanks for your time.